Well, hi there. This is Chris Fregley from Amazon Web Services. I'm a developer advocate focusing on AI and machine learning. So today we're going to talk about how to build personalization models using Amazon SageMaker. So here's the agenda. We'll talk about, first of all, why should you use personalization in your applications? What are some of the popular recommender algorithms? Why should we build these recommender models on AWS? Which options to train and tune recommenders do we have with Amazon Web Services? We'll also do a demo where we actually build and deploy and tune a TensorFlow multitask recommender. We will conclude by discussing how to scale these recommender models into the millions. Why should you add personalization to your applications? Personalization is pretty much everywhere. If you recall going into the video store many years ago and trying to decide which video to watch with your family, you had to take into account lots of different personalities. You also had to take into account your mood at that time. And so this is something that I personally have found much more useful about online shopping, online video selection, with services like the Amazon Prime Video, like Netflix, such music services as Spotify, Pandora. These services actually help me to understand what I'm actually in the mood to watch or to listen to at that moment. And so here's an example showing personalization throughout the application. We have movie recommendations showing up here, what to watch next. We see different box art is the term for this, where it's different facial expressions depending on, and so depending on your mood, you might actually be more prone to select certain box art based on what they're showing. And so, yes, oftentimes this box art can change. And so behind the scenes, some of these recommenders, these more advanced personalization algorithms, can actually detect what mood you're in, or that you've seen the same box art 2 or 3 times, and now they'll show different box art, which certain parts of the world, for example, seem to like stoic, sort of flat expressions. Certain parts of the world seem to like very happy. Some will prefer sad. Some prefer just one person in the actual box art. Some prefer the entire cast. So it really depends. And the ability for your application to narrowly target these types of users and within that particular session that they're interacting with the application is super powerful. There's also time of day ranking as well too. So depending on if you're busy at work, if you're if it's sort of evening time and it's after dinner, certain recommendations will show up. So for example, during work hours, you might not want music that's new. You might want familiar music and you could just listen to while you're working. But in the evenings, you might be more interested in something new, either a new movie, a new TV show, a new song, something like that. There's also customized channels, of course, dynamic channels that can be created depending on your mood or depending on what you have recently watched. Personalization, there are like many benefits to businesses with personalization in their application. So yes, as I mentioned, people's tastes are different, preferences, different times of day, and their specific needs are different. And so building one model for all users across the world is just not the best use of your machine learning. And so what we want to do is bring in new customers and then retain the existing customers. This is very important. This is common throughout all applications that we build. We want our customers to be able to discover new products and new services. And so that's discoverability through search or through these sort of recommendations that are showing up on the home page. We want to improve the engagement too with the website, with the application, with the specific content. Yes, ultimately this all leads to sort of increased revenue for the business. This will typically lead to increased conversions, clicks, watches on your video streams or listens on your audio streams, purchases with your e-commerce app. So things like movies, restaurants, music. So here's another way to sort of highlight how personalization can be used here. So personalized recommendations, we should be delivering high quality recommendations that are targeted to specific users. I've mentioned also about sort of real-time intent and mood. So these are things that can be helpful, which I didn't have back when I would walk into the video store. Now, when I'm online, I can very quickly go through different sets of content and do searches, and I'm not, going up and down aisles of a video store and then potentially getting something when I come home that I don't like. I could read other people's reviews, right? And so here I can train a recommendation model with just a few clicks. We'll actually have a demo of this here in a bit. And then the ability to just generate recommendations for pretty much everything and to cross different product categories. So I can make recommendations for movies. If you like Devil Wears Prada, the movie, maybe you also like Prada sunglasses. So here's some of the challenges for building these effective recommenders, right? First of all, time-based, super important. This is really the most current sort of next level way of doing recommendations. And so the ability to respond to changes in the user's mood intent. Like cold start problem. So this is where let's say new movies come online and or new products come online into our catalog. We don't know anything about those movies yet. Maybe we just have simple data like the genre, if it's a comedy, if it's a horror, but there is yet no user interactions with that content just yet. Also, when you first sign up, right, these systems don't know about you. So you could either get through a quick survey, if you do like comedies. So this is the cold start problem with these recommenders and is a very real problem. And then popularity trap. So this is a case where we are constantly showing the most popular movies, books, items to a user, and not exploring sort of unpopular titles or not yet popular titles. And so you really want to try to avoid popularity trap, because otherwise it'll be the same 10, 20 movies for all customers worldwide, which might not be what you want. And then scalable. So of course, as your site scales to the millions of items and users, you certainly want to be able to keep up with this. And then of course, custom models, being able to build customized models specific to users. And we'll talk later on at the end about how to automate this whole recommendation pipeline and actually build one model per user, which will then lead to millions of models and very, very highly targeted recommendations, which is super useful. So what are some of the popular recommender algorithms? Back in 2006, Netflix actually launched what is sort of like a modern day Kaggle competition, where they asked the community to come up with one algorithm or a set of algorithms, sometimes called ensemble of algorithms, that could improve the recommendations that Netflix was currently making at the time in 2006. And so Netflix, they had open sourced a data set. They had masked as much information as possible so that there was minimal PII leakage, like personally identifying information leakage. And the public was then able to start to train models. It took about 3 years to actually win this challenge. 2009, a bunch of groups came together. The final winning team was called Belcor's Pragmatic Chaos. That actually was a few different teams coming together towards the end. And so out of it, I believe the final submission had over 150 algorithms that were ensembled together. Now, 150 algorithms might have really worked well for that single data set over 3 years of training, but was not feasible for the compute that was available back in 2009. So one of the algorithms that actually surfaced is called collaborative filtering, and the implementation is called matrix factorization. And so these next couple slides, I'll show you how that works. We'll show you how to actually implement this on AWS. Okay, so this is matrix factorization. The idea here is on the left, you have the user item sort of interactive matrix. And so this is feedback that the users have given to the system and have actually said this particular this particular item, so let's say movie, that user chose to give it a 3.0. Another movie and a different user gave 4.0, and then so on and so on. So each row is a user, each column on that left matrix is a movie item, for example. On the right is actually taking all of that sparse matrix on the left and factorizing it. So similar to like an algebraic factorization where you have one number and you want to find two factors, we are doing a matrix factorization. The end result is that we have this user factor, and so that's one matrix, and then there's an item factor matrix. These are sometimes called the embeddings. And so what we're doing is actually learning these user and the item embeddings, which we can then recalculate and fill in the rest of that sparse matrix. Okay? Now we can sort and then figure out what to actually recommend to the user. Of course, we would want to pull out things that the user has seen already. And so some of the hyperparameters that we'll see for this matrix factorization, there's something called K. That's the rank of this matrix, and that's the number of sort of latent features. Now the term latent feature sort of means hidden feature. It's not necessarily humanly grokkable, so this is a hyperparameter that you want to specify and tune. And so I'll show you soon how to actually tune these things using AWS and SageMaker. Okay, what we're trying to do is actually minimize the root mean squared error. This is the main metric that we are trying to minimize. So if we had 0 error, that means all of our predictions were correct. And so obviously that's not the case, but we do want to sort of minimize. So we'll try different K values, try different hyperparameters, and then we will minimize using hyperparameter optimization in a bit. And so we would first calculate the actual error. So if we predicted a 4.2, but the actual was a 4, then that error is 0.2. We square it just to get rid of that negative. And then we then take square root, and then that's the actual metric that we'll use. There's something called multitask recommenders, which we will dive deep here in a sec and show a real world demo, and I'll share the code with you as well. So this is where we are going to actually optimize 2 different objectives. So before I mentioned that we were optimizing one single root mean squared error. Here, we are actually going to choose 2 different optimizations. We are going to then optimize them together. So there's actually 2 data sets that we will be using here. They're both actually technically part of the same data set, but it's just different views and different features generated from that same data set. So we will, of course, look at the ratings like we did earlier with the matrix factorization. And so 0.5 is the worst, that's a half star, and then 5.0 is 5 stars, that's the best. We will also look at if they watched it or not. And so that's sort of that's the implicit feedback. So the explicit feedback is what the user actually gave for that particular item. If it was 1 star, if it was 2.5 stars. But then there's the implicit feedback, which is whether or not the user pressed play. And sometimes, and typically, we do it where it would be 5 minutes of play. So just clicking play might not do it, but that's up to your domain to be specific. So what we're going to do is try to optimize both of these in the same training run. Now there's transfer learning happening as we're actually, we are going to optimize one and then transfer that knowledge into the other and then back and forth. So this is what we'll be doing a demo here in a bit. Before we get to that though, let's talk about why should we build these on AWS. So just real quick, yes, Amazon has 2 decades of experience building recommender systems. Of course, Amazon.com. We've seen some of these recommendations here where it is customers who bought this item. They had also bought like these items, so maybe you might be interested. This is called collaborative filtering. There's been papers that have been published by Amazon on this. Patent was filed, and this feature was launched back in 1998. This is one more paper here. This is one of the, I think this is from 2003. Super good paper talking about the item-to-item specific collaborative filtering. So there's user-to-item, which is how users interact with these items, and how those interactions can help you predict and like make recommendations. Right, then there's item-to-item collaborative filtering, which is a slight spin on the user-to-item. So check that out. So what are the options that we have to actually train and tune these recommender models? Yeah, so AWS has something called Personalize. And so this is Amazon Personalized Service. It's sort of an AI, no machine learning required type of service where you just point to your interaction data, what users bought which items, and from there, all the timestamps and everything will get consumed. We build, right, like many different models. And really is a form of like auto ML, but it's all being done behind the scenes. And so Personalize is a super fast way to get started and to get a baseline set of metrics for your data set, and then build a set of like personalization models for your users and your catalog. On the SageMaker side, so for those of you that maybe want to dive deeper or want more fine-grained control or want to use a newer, like brand new model that was just released, or has like your own model that like you've already created that's specific to your domain, you would then want to go the SageMaker route, which gives you more flexibility, gives you more hands-on, but does not require all the infrastructure that you would require on your own if you didn't use SageMaker or didn't use Personalize. So SageMaker is a really good option. So SageMaker has something called Autopilot, which gives you auto ML. So that's automated machine learning, where it can discover based on your data set and your learning goals. If you're trying to like generate recommendations, yes, AutoML will recognize this and can then start to do its own hyperparameter tuning, right? So again, all you do is point your data. I'll show 2 or 3 other ways that you can train models with SageMaker, even lower level, and gives you super tight control over what your training models are doing. All right, so sort of at the top of the stack would be the SageMaker Studio IDE. This is a great product based on Jupyter Lab. You can build your own extensions, you can extend it if you want, or just use the like built-in SageMaker Studio. And this will give you access to the experiment tracking, to various features where you can compare experiments, you can track lineage, things like that. There's also built-in algorithms. So SageMaker comes with something called factorization machines, which is obviously a like implementation of matrix factorization, which we showed earlier. We'll show you that. There's also a way to do serverless Apache Spark. So not a lot of people know this, but SageMaker supports Spark. And this is done through something called processing jobs, which was released, I believe, December 2019 during a like reInvent. SageMaker training and then hyperparameter tuning. This is what we'll actually do the demo, and we will go through this in a bit. This gives you super low level. You bring your own train.py file with your own frameworks. You could use TensorFlow, PyTorch, MXNet. You could use scikit-learn. You could use Spark. You could use anything. So let me show you. So Studio. So here's a quick look at Studio. Some of you might recognize it because this looks very similar to Jupyter Lab. If you notice, we have some like built-in extensions. If you see the little beaker, that's for the experiments. There's more coming in the future, so keep an eye out for that. Studio is really the main IDE of SageMaker, and this is where you can compare experiments and then visualize trends and model quality. Built-in algorithms. So here we've got the factorization machines. And so let's see here. So this is where we can actually scale out So this is out-of-the-box matrix factorization. And this is where we can actually scale by just changing one number, which is train instance count. So we can maybe train on a small data set with just one instance, but then once we actually get some results back, we can then scale up that training. And let's see, we specify training data there. This is how to do hyperparameter tuning. You can set hyperparameters. We'll actually cover hyperparameter tuning in more detail in a sec. So processing jobs, this is that serverless Spark. So here you actually provide your own PySpark script in Python. You can also use Scala if you have Scala. Certainly supports that. Keeping it to Python because this really seems to be the data scientist's choice of language. So if you've ever seen the alternating least squares like algorithm as part of Spark ML, it's an implementation of like matrix factorization that can be parallelized and scaled across many Spark nodes. Okay, so we will actually scale this across 10 of our SageMaker nodes, R5 2XLs. We're using R5 because Spark likes to use a lot of RAM. It's very efficient that way and then very fast. We specify the PySpark script right here, pass it the inputs, pass it the outputs, typically S3 buckets, and out comes our trained models and the recommendations. Okay, here is, so here's really, where if you have your own model, your own either scikit-learn, here we are using TensorFlow and specifically a like newer library called TensorFlow Recommenders. And this came out, I believe, in September 2020, maybe August 2020. It's a super cool library and really nails down the sort of recommendation space. So like traditionally TensorFlow did not support recommendations in a way that we were used to from Spark and from matrix factorization and the sort of collaborative filtering based. And so that's where TensorFlow Recommenders comes from. And so, yeah, you should check it out. Train.py, again, we're specifying the Python script. This is TensorFlow. Giving a Python version of TensorFlow here, we're using 2.3. Passing in hyperparameters, we will revisit this in a sec. When we do hyperparameter tuning, we'll actually pass in specific ranges here. This is hyperparameter tuning. So here we are saying we want to try learning rates. This is specific to the type of optimization that we're doing. The embedding dimension, which is a hyperparameter used. So this is essentially K, right? The embedding dimension is K that I had mentioned earlier. So here we're trying 32 or 64, exploring learning rate between 0.00001 and 0.00005. We're trying different epochs, which is complete passes through the data set. Here we're giving it hyperparameter tuner. This is built into SageMaker with just a couple lines of code. Here we're using the random strategy. You can actually use Bayesian as well as just regular grid search. You can say how many jobs that you want to actually explore. You can also, if you wanted to change this to 10 jobs total, and then do 2 at a time, if you were using Bayesian, that's optimal because like Bayesian likes to learn from previous sets of jobs. All right, this is where we'll do the demo. So, okay, so this is actually using that TensorFlow Recommenders. This is version 0.2. This is going to be multitask training. So this is where we are actually going to train 2 different objectives at the same time. So we're specifying our S3 data. We're also tracking which metrics, and so here we're specifying root mean squared error. So that's the main metric that we are going to optimize and to actually report on. We're going to make 10 passes through the data. We'll start off not hyperparameter tuning. We'll just hard code and manually hyperparameter tune, basically. We're going to do learning rates as 0.00003. We're going to use K, the embedding dimension, as 32. We're going to use a GPU P3 type. Here we're specifying multitask.py. Passing all that in, we're actually going to create the experiment. And so this will then show up within Studio IDE, SageMaker Studio. Here, yes, everything comes together with this estimator.fit. Pass in the dataset, pass in the experiment configuration. We would then wait for the job, which we have already run. So now we're going to pull down the model just to show you that you can train the model with SageMaker, then pull it down and inspect the model, or pass it to an application team. This is the signature, so we see we've got user ID coming in, and then we have 2 vectors coming back, which is the actual recommendations. And here we're capping at 10. So this is the actual train.py file. So this is the sort of low-level TensorFlow code. We're actually using Keras as the sort of higher level API. Here we're setting up the loss function. Here we're actually parsing all of the SageMaker. So when we run on SageMaker, SageMaker passes us context information, how many GPUs, passes in all the hyperparameters for us. We then use those. We load the data set. So here we're using Movie Lens data set, very popular recommendation data set, and setting up our optimizer. Here we're using Etagrad, passing in learning rate. That's a hyperparameter that we are going to use and then tune next. Setting up our model, compiling, calling the evaluation, or first calling fit and then calling the evaluation, and all of that comes together. And we will, so let's optimize this model. And then we will, in this example, optimize. The next notebook, we will actually deploy and then make predictions. So the optimize looks actually pretty similar to train. It's going to use the exact same .py file, train multitask.py, except we're not passing in all of the hyperparameters through hyperparameters right there. We are actually going to pass in ranges. We are going to pass in ranges of hyperparameters that we want the hyperparameter tuner to explore. So here we're actually using Bayesian, max job 6, and we run the job. We will get back the results. Let's actually look at these specific results. There's something called hyperparameter tuning job like analytics that's built into the SageMaker Python SDK. And here are the results. So here we see that the embedding dimension K of 64 seems to that seems to be the smaller root mean squared error, which is what we are trying to minimize. So moving forward, for example, that's the model that we will then deploy because it is the better model. So let's actually deploy a REST endpoint with SageMaker. This is the architecture here showing where the data comes from, training, where the actual images come from for training and for the inference. So the best model was stored in a previous notebook. We're pulling it down again just to make sure that it has the right signature for TensorFlow serving to use. And then here is where we're actually making these predictions. Actually, this is just operating on the local model. So we still have not yet deployed. We just pulled it down, made predictions just to make sure that code works. This is the inference.py. This is what's going to convert JSON into tensors, and then the result will be then tensors back into JSON. Here we're actually deploying the model. And setting up the predictor, and then this is when we actually call the REST API here, and those are the predictions. So Jane Eyre, we've got the Abyss, we've got Showgirl, Scream, Yeah, we have Amityville Dollhouse. So pretty interesting set of recommendations. All right, so that's the end of the demo. So how can we scale to millions of recommender models? This would be one recommender model per user, for example. So of course, you want a pipeline, a nice consistent pipeline where we can retrain as new data comes in, but we can also segment the data out or focus in on specific users and run sort of millions of these, what I call micro pipelines that are specific to each user, and just constantly like churning these out. And when we do that, because of the like lineage tracking that SageMaker, the experiments, gives us, we can also version these models. We can then audit them. And yeah, so basically all of this comes together. There is new data that first we would explore with SageMaker notebooks. We would then train, do some hyperparameter tuning. We then deploy it, and then the sort of end user applications can then talk to those models. We can also do batch transformations as well too, batch predictions. That's super easy with SageMaker Batch Transform. Here we are just highlighting some of the REST APIs because they're fun. In summary, yes, Amazon has 20 years of experience doing personalization and building recommender models. There are many ways on Amazon Web Services to actually build these recommender models yourself. You could point either with the personalize service, which just point your data and then no machine learning is needed. We have SageMaker. We have different levels of SageMaker. You could do everything from just sort of notebook, one-time training all the way through hyperparameter tuning, and then of course building full pipelines to then automate all of this. So you can also use whatever AI framework that you want. So like you could use TensorFlow, you could use MXNet, you could use PyTorch, you could use scikit-learn, you could use Spark. Many different options. You can also do use reinforcement learning also. So this is not sort of as well known, but there are deep learning containers. There is first-class support for reinforcement learning on SageMaker. And that's going to be things like Vopal for multi-arm bandits, for example. You can use Ray, Coach. So these are all very popular reinforcement learning, certainly possible with SageMaker, first-class support for RL. You can then choose the best option. Because there are so many options, you would then choose the best option based on your specific environment, your domain, your data set, your skill set also from your team. You can scale to millions of these recommender models with clean end-to-end pipelines using SageMaker. So for more information, here's a couple cool links. So there's a blog post, there's the full set of examples from like today's talk, and a new book that's coming out here. Also, this will be early 2021. This is actually the early release is online right now. So go check it out and have a great conference. Thanks.